Good afternoon. Hi, everyone. So my name is James Guthrie. I work at Timescale. I work on a product called PromScale. You may have heard of it before. You can probably tell by the name, it started its life as a Prometheus remote write storage backend, but nowadays it's kind of like becoming a storage backend for all sorts of observability data. So we store traces, we store metrics, and we're going to do more stuff in the future. But when we were looking into OpenTelemetry Metrics, we kind of realized that there are some differences, and that was kind of how the idea for this talk came about. So before I really get into things, I kind of want to see what's going on in the audience about like what people actually know. So the previous talk, they asked how many people are using Prometheus in production. I saw a lot of hands go up. So how many people were aware that OpenTelemetry Metrics became generally available earlier this year or late last year? OK, so about a third of the audience. OK, how many of those people spent some time to think about, like, OK, OpenTelemetry Metrics, what am I going to do with this now? 5, maybe? OK, how many people are actually running anything that uses OpenTelemetry Metrics? 1. OK, and how many people are using OpenTelemetry traces in their production setups? OK, quite a few more. So about 15, I guess. Cool. So when it came to putting together this talk, I realized that OpenTelemetry Metrics is kind of a jungle. There is a lot that one could talk about, and it would not fit into a 20-minute talk. So I had to kind of like try and find a path that goes through that jungle. And the point of view that I've chosen to take in this talk is, as you could see in the title, the operator's point of view. So I'm basically not really going to cover anything about how do I instrument my application, which SDKs do I use, how do I do all that stuff. I'm not going to talk about any of that at all. I'm basically going to talk about it from the point of view of if you are operating an existing Prometheus setup and somebody comes and says, hey, I have this thing, it's doing OpenTelemetry Metrics, what are things that you need to kind of think about or care about? So a couple of the questions that I'm going to try and answer today are, what do I do with an app that's been instrumented with OpenTelemetry Metrics? Can I just like plug this thing into what I already have? And what things do I need to kind of be aware of? So let's start with some easy things. First off, is OpenMetrics the same thing as OpenTelemetry Metrics? I was at a conference a couple of weeks ago, and somebody had this idea that, like, oh, you know, the name is kind of the same, it must be the same, right? The answer is no. They are not the same thing. So the next question you may wonder is, like, is there some sort of interoperability between these things? And the answer is yes. There's kind of been an explicit design goal of the OpenTelemetry Metrics people to make Prometheus and OpenMetrics work with OpenTelemetry Metrics. So they do interoperate well. So you may say then, OK, well, so there's nothing I need to worry about anymore? And the answer is, well, kinda. And that's why I'm here today. So let's start with something that you will know. This is kind of like also, again, the operator's point of view. This is how you will kind of see your world as with metric collection. So we've got a service on the left. It's exposing a Prometheus metrics endpoint. We've got a Prometheus in the middle. It's got a list of targets. It's scraping the targets. It's getting the metrics. And maybe we've heard a lot about different long-term storages. Maybe you're using remote write to write into a long-term storage. So what does this look like in the OpenTelemetry Metrics world? Well, in OpenTelemetry Metrics, we have our service. It's instrumented with the OpenTelemetry Metrics client libraries. It's pushing data using this OTLP, the OpenTelemetry line protocol, which is their way of sending data, into a telemetry storage box. So I know you're seeing this, and the first thing that's going through your mind is, oh my god, like it's doing push. Like the Holy Tome of Prometheus states, "Thou shalt pull thy metrics." And so we can't really do anything with this. And by the way, if you haven't received your Holy Tome of Prometheus yet, they'll be available at the end of the conference, together with the 7 cardinality sins. But anyway, back to business. So the fun thing about OpenTelemetry Metrics is this box here, this telemetry storage box, it isn't really defined what it has to be able to do, aside from ingest metrics. So there's no API definition. There's no query language definition. There's a bunch of stuff that you would be used to having in the Prometheus world that you will just not have in this box, at least not by definition. And it's also kind of like not a goal of the OpenTelemetry project to standardize those things. They're not going to standardize APIs. They're not going to standardize query languages, or at least they don't want to for now. So what is this box in reality? Well, there are a bunch of vendors that want to be this box. That's kind of why OpenTelemetry exists in the first place, so you can have this interoperability between different vendors who are trying to provide services. So some well-known examples that you may be aware of are a pivoted dog dating service, collector of relics, people who like to step on lights, and some honeybees. So there's also a growing ecosystem of open source solutions around OpenTelemetry Metrics, but none of them really will give you the features that you're used to out of the box with Prometheus. And I know that at KubeCon NA, Guthrie had a talk basically on the same material as this. He mentioned that there are ideas in the Prometheus world of actually integrating OpenTelemetry line protocol so that Prometheus would be able to just receive OTLP metric data. Yeah, there were a couple of people in the audience who are familiar with traces. OTLP, you'll know that from there as well. It's kind of the same thing. So actually, there's one omission on this slide. Click. Oh. It works as a mouse pointer, so it's doing stuff on my screen now. There we go. OK. In reality, you'll actually set up your collection pipeline like this. So your application will push into this thing called a collector, and the collector will push into your storage backend. And actually, I kind of lie on this slide as well, because as far as the OpenTelemetry project is concerned, this is how metric collection works. So your service can be instrumented with OpenTelemetry, but it can also be instrumented with other things. It can push, but you can also do pull over here. You can have the collector pushing, or you could have pull from some sort of storage backend here, and the storage backend doesn't have to be OTLP. So there's a lot of flexibility in the model, which is cool, but also at times a little bit annoying. So I'd like to take a look at some of the different ways that you can configure and use the collector in setups that you may be familiar with. So this diagram we saw before. I didn't change anything. But now somebody comes along with their Snowflake service, and they say, hey, we did this thing, and we used OpenTelemetry Metrics. Super cool, right? And you're like, well, but we used Prometheus here. So what can you do about this? Well, here you can basically plug in the collector as a sidecar. You have your service pushing OTLP metrics into the collector. The collector can expose a Prometheus-compatible text format exposition endpoint, and you can just configure your Prometheus to scrape from there. So problem solved. Now, maybe somebody else comes along and they're like, oh, so I've done a second service because the first one was so cool. So maybe you need to like promote this thing that was a sidecar into a service, and you can still scrape it from your Prometheus. And we can kind of take this a step further, and maybe you don't have any Prometheus services anymore, or instrumented with Prometheus, and you can have all your services pushing OTLP into the collector, and the collector can then remote write into your long-term Prometheus storage. And now somebody comes along, I don't know, from upper management, and they say, oh, we need to integrate with this external pivoted dog dating service, so we need to get all the data in there. Oh, wait, sorry, that was one slide too early. Yeah, we can go backwards as well. We can go back to a service which has Prometheus metrics, and we can scrape them from the collector and remote write them. And now comes the thing I was saying before. You can integrate your dating dog service via OTLP, as well as having remote write into your long-term storage. If there's anyone from Datadog here, please don't hate me. How does this work? So this diagram I lifted from the OpenTelemetry Metrics, actually OpenTelemetry documentation. It's quite complicated. There are lots of boxes, but let's focus on the simple bits. So there's this vertical pillar here. This is called receivers. On the right, we have exporters, and in the middle, there are these processors. And basically, you can wire up your collector to kind of get data from different input sources you can route them through different processors, and you can have them exported to different data sinks. So this green line, for instance, we're receiving OTLP data, it's going through some sort of batching and filtering, and then it's being stored in Prometheus in the end. So there are a ton of receivers, like 30 or 40, something like that. There are a couple for Prometheus, one for Scrape, where basically you just configure it as you would your normal Prometheus, and it'll just scrape everything like Prometheus does. There's Simple, which is intended to only scrape one target. There's OTLP, obviously. And then the interesting thing is that there are host metrics and Postgres. And one thing I didn't mention on the previous slide is this exporters thing. You guys know exporters from the Prometheus world is like this thing that you run next to your application and it exposes metrics. It's not the same thing here. They took the exporters term and they did something completely different with it. So not the same thing. But interestingly, or confusingly, the collector receivers do the same things that exporters do in the Prometheus world. So this host metrics receiver, for instance, is the same thing as the node exporter in the Prometheus world. It's a collector or a thing that basically will pick up metric data from the host that it's running on. And similarly for Postgres, you can have a receiver, which is basically connecting to a Postgres database and getting data out of it. There are also a bunch of exporters. There's Prometheus Scrape, which basically exposes metrics endpoint in text format. Remote write, we saw that before. OTLP, Elasticsearch, a bunch of other vendors. And there are a bunch of processors that you can use for batching, sampling, renaming, adding attributes, doing cumulative to delta conversion, which we'll see in a second what that's about. So far, so good. We've seen unicorns and rainbows. This is how we can connect all these different things together. Everything works beautifully. But does it? So there are some differences. There are differences in the metric data types, differences in naming conventions, differences in temporality, and differences in metric types. So let's go through these bit by bit, and we'll kind of like build up a picture of what's different and kind of what's the same, I guess. So the first thing is kind of a minor detail. OpenTelemetry metrics can be either floating point or integers. So you need to do conversion from integer to floating point in order to store them in Prometheus, which is probably not a problem most of the time. But if you get above a value above 2 to the power 53, then you start to lose precision in the numbers, and maybe that will mess with your life. Also, metrics always have an associated unit, and that unit is well defined. But what's interesting is that the semantics around the units are slightly different, or conventions around units are slightly different to how they are in Prometheus. There's a whole, because they're all standardized in OpenTelemetry Metrics, there's a whole linked document of how you should use different unit types and so on and so forth. Basically, it's not necessarily the same as in Prometheus. So whereas Prometheus, you kind of like standardize on using seconds, in OpenTelemetry Metrics, you can do kind of whatever you want. That brings us to naming conventions. So you may be familiar with this guy, Go memstats heap alloc bytes. This is a metric which is exposed by the Go runtime, how many bytes are allocated on the heap by the Go runtime at that point in time. So if you're scraping or getting metric data from a Go application, you'll be familiar with this. Now, in the OpenTelemetry world, obviously there is a Go client library that you can use to instrument your application, and will also expose a value which tells you what the allocated heap bytes are. But in OpenTelemetry metrics, this guy is called process.runtime.go.mem.heap.alloc with the unit of bytes. So the name is very different. And this name comes from these OTel Metrics semantic conventions. I've linked the document here. It's interesting to go through and see kind of like how they see the world. It seems like kind of a nice way to look at things, but the bottom line is it's different. So one of the first things that you'll probably notice is, well, this name includes dots. And Prometheus metrics don't have dot names in them. There was an interesting discussion yesterday. Björn was saying how he wants to use dots to be able to do something in the PromQL language. And I also heard somewhere before that there was the idea of maybe allowing Prometheus to allow dots in the names. So these two conflicting ideas, I don't know, have to figure out what's going to end up happening there. But how is this dealt with in the exporters? Well, the exporters will do normalization. So the slide has got way too much text on it. So basically, the simple normalization will strip everything that isn't compatible and replace it with underscore. So we can go from process dot runtime dot to process underscore runtime underscore. And then there's an alpha level feature which you can activate in the exporter to do full normalization, which will kind of basically take a look at the underlying metric type and then append the unit at the end of the name because it knows what it is. But it won't do conversion from the different unit types. So if you have the unit as milliseconds, then it won't convert it to seconds for you because that's like the standard in Prometheus. At least not yet. Maybe that will be done at some point in the future. But now, an important point to note here is this process underscore runtime blah, blah, blah thing. This will be eaten by Prometheus, but none of your queries that you've written will work against it, right? Because you're used to using this guy, go memstats heap alloc bytes. So if you want to have your queries working, then you need to either rewrite your queries or do some sort of like renaming of the metrics as they go through, which kind of is a bit of a pain. So there's definitely some pain to be had there. Next is temporality. So OpenTelemetry Metrics knows about cumulative and delta temporality. Now, these are kind of like complicated names. Cumulative is basically what Prometheus does today, which is you start counting, basically, or keeping track of metrics. And as time goes by, you just keep on adding data that you collected, So if you have a new label that appears, then you'll keep track of that new label and all the old labels for a metric over time. What this means, though, is that the instrumentation client code is going to have state stored in approximately proportional to the cardinality of the labels in the application. Now, delta temporality is basically a thing where instead of keeping track of everything from the beginning of time, you kind of break it up into time intervals, and after each time interval, you forget everything that you had before, and you just sort of like transmit what you've seen so far. So here we can kind of like basically break the stream into this time bucket here, and we can send that data. Now, obviously, this is enabled by push. You can send that with push at your own desire to an external service, and then you can basically reset your counters to 0 and again, reset and count again. So what this means is that your client code basically ends up becoming stateless because you don't need to track all the state that you've seen over time, but it's only enabled by being able to do push. OK, so how is this dealt with in practice? In practice, the Prometheus exporter will accumulate delta metrics. So I didn't actually mention this, but when you instrument your code, you can choose to do it cumulative or delta. And so if the Prometheus exporter receives delta metrics, it will accumulate them, whereas the remote write exporter will basically say, delta, can't do this, drop it. There is no processor, which you would kind of maybe expect. Like you could just plug in a processor to the collector, and it would do the delta to cumulative conversion. That doesn't exist. But that's not because it's not wanted. There is an open issue. So if you feel like stepping back from your YAML, then maybe that would be something you could do. Finally, going to look at metric types. So I have quite a few slides on this, but at the end of the day, the amount of information is actually relatively small. So Prometheus has these 5 different metric types. Sparse histogram is new, yay. And for most metric types, there is compatibility or a path to compatibility between the OpenTelemetry metrics and the Prometheus metrics. But the names are slightly different. So we'll look at this from the point of view of the Prometheus metrics. In Prometheus, we have the counter. And there are 2 types which map from the OpenTelemetry world. They're both called sum. So OpenTelemetry has we saw this delta and cumulative. They also have the concept of monotonic and non-monotonic. So basically, monotonic is only increasing, and non-monotonic can be going up and down, like a gauge. But if you have delta and non-monotonic, it's kind of like a slightly different thing, where, for instance, if you had a queue, you can say, well, I know that I'm putting 2 items in this queue, and I know that I'm taking 3 items out of this queue, and you can actually keep track of those differences over time, which can help you to glean a little bit more information from the underlying thing than if you just had a counter which you kind of occasionally sample and see sort of what the current value is. Anywho, basically, the sum of a cumulative monotonic value is the same thing as a counter. So OpenTelemetry world, cumulative monotonic, same thing as a counter. A delta monotonic can be converted by basically adding up the deltas into a cumulative series, and that's the same thing as a counter. Then there's the gauge type. I said that there are cumulative non-monotonic. That's basically you can add positive and negative numbers to it, so it can go up and down like a gauge. They have this as a separate concept in OpenTelemetry Metrics that maps to a gauge. And gauge also maps to a gauge. They have that type as well. There is a missing mapping, which is the sum of delta non-monotonic, which I kind of mentioned before. Those are not mappable. They'll be dropped. Yeah, so if any of your client applications actually use those, gone. Then histogram also has delta cumulative, can be mapped as well. Summary, I think, basically exists in OpenTelemetry Metrics for compatibility with Prometheus, also exists, also mapping. Sparse histogram maps to exponential histogram. I mean, it can be mapped, but the sparse histogram or native histogram is so new that there's no actual mapping yet. But I think that, or I'm assuming that people are going to be working on this soon. So we began by asking, what can I do with an app instrumented with OTel Metrics? And can I just plug it into my existing Prometheus stack? And the answer is yes, basically you can. We also asked, what gotchas are there that I need to be aware of? And the answer is there are a few. We saw them. We didn't see them all. There were more. I couldn't cover them all. So just be aware that if you ever go down this path, you probably will stumble across a bunch of different things. And maybe you'll need to look for help from others that have been before you. If you'd like to do some more further reading on this topic, my colleague James Sewell wrote a couple of articles, one a deep dive into OTel Metrics, another Prometheus versus OTel Metrics. If you have any questions, I'm available. Thank you.
All right, questions? Got one right here.
Hi, James. Thanks for the presentation. I guess my question is, a lot of the caveats, you did preface this by saying that kind of OpenTelemetry gives you portability with your metrics. But I guess in this particular case, if you were producing Prometheus metrics and then converting them into OpenTelemetry metrics and then writing them back to Prometheus, kind of what's a practical use case for that kind of additional step where you're going into something that's more abstract, that's not specific to Prometheus? And kind of a question that leads on from that is a lot of these third-party vendors accept remote write as a method of writing metrics to them. What are kind of the pros and cons of both approaches? Why would it be beneficial to pick one over the other? Thank you.
Okay. I think I can give a partial answer to that. One thing that can be a motivating use case for using OpenTelemetry Metrics is having push. There are use cases where push is well suited to, and that are not very well suited to the existing Prometheus world. So for example, if you have IoT devices, things that want to have a small memory footprint, things that don't have continual access, that you don't have a continual access to because they don't expose an IP address, they're not on the internet or something like that. Or things like function as a service, or kind of like very lightweight services where they're very ephemeral. They just kind of, they come and go, but you don't really have control over them. That might be a use case where you would want to think of using the OpenTelemetry Metrics pipeline just because it has delta. But aside from that, yeah, I mean, I think it's kind of having Prometheus and then kind of scraping that via the collector and then putting it back into Prometheus again, maybe not the smartest.
You mentioned a few different mappings between the two different types. Mm-hmm. Are there any other data types from OpenTelemetry that aren't mappable?
I don't believe so.
Anyone else? Hand up? No? Okay. So we're a bit ahead of schedule. Unless somebody comes and tells me otherwise, we got a break until quarter after. So thank you very much.